directly start, have fun. It's your
Okay, that's indeed the idea, having fun with Java and JavaFX on the Raspberry Pi. Thanks for having me in this amazing virtual event. Um, I'm Frank Delporte. I live in Belgium. I do a lot of blogging on webtechie.be, just some experimenting stuff and things which interest me. And I do programs since I was 10 years old and I got this Commodore 64. So yeah, indeed, that's 35 years ago. Damn, I'm getting old. Um, and important to note is that I didn't use that computer a lot for gaming. I only had one game, but I found a book by then. I was 12 or 13 years old. I found a book how you could connect electronics to that Commodore and control a relay board. So, a relay board with a little power, you can control, put something on and off with much more power. And I use it to control my Lego trains. So I had my Lego trains control center in a Commodore 64. And that's how I got interested in everything related to programming and electronics. Um, the last 10 years, I worked at Televic Rail here in Belgium, and we make passenger information systems, and the most visible part is these screens, but it's also LED displays and speakers and alarm panels and cameras and stuff like that. But what you see here is real-time passenger information brought to the trains with Java. So on the wayside, we have Java services to collect all these data and then bring it to the trains to show it on these displays. So on the upper right, you have the London Underground. The lower right is connection information in the next station. So it's a challenging environment with trains completely losing connection and getting connection back. So they switch from Wi-Fi in the stations to mobile connections while they're driving or losing the connection. So it's a really challenging environment where we bring this information to the trains. Unfortunately, the screens you see, it's web-based, it's not JavaFX. I joined the project 10 years ago when it was in the very early stages. And at that time it was Flash and then it moved to HTML. And JavaFX was not really in the picture, but we were already using Java to control everything. About 7 years ago, I also joined Coder Dojo. It's a volunteer-led project where we inspire kids into computing in everything related to programming, but also working together, presenting what you're working on, and the volunteers, the coaches of these kids, bring their own interests to this event. So you have coaches who do Java programming like me, but also others who are working with Arduino of Raspberry Pi or whatever, and they bring it to this club to teach it to the kids. But of course, the other coaches also learn from it. And that's where I got into contact with this Arduino and Raspberry Pi, this cheap electronics, and the amazing stuff you can make with it. And about 2 years ago, I was building this drum boot for my son, and I wanted to have this user interface for him to control lights, and it's all connected to a Raspberry Pi and an Arduino. And he can switch on and off again with relays. He can switch on and off lights of 220 volts, 15 volt. There are different lights there, and the Arduino is used to control these LED strips. And inside the Java application, there is also a web server. So we can, from everywhere in the house, toggle the red light signal. That means that dinner is on the table and he has to come down, and we don't have to shout from down the stairs that he has to stop drumming because he never hears us, of course. Now, all this led to a 4-page article for MagPi, and a bit later I had a book which is available on LeanPub and on the Elector website. And it handles, of course, the start. How do you program with Java? Some crash courses. How do you start working with the Raspberry Pi? What electronics can you connect to it? And a lot of sample applications. for instance, with electronics like this 8x8 LED matrix display, small LED segment display like you have in a clock. It's used to explain bits and bytes, and then get the weather from an open API and display it on an LCD. I have a Spring application with Swagger REST APIs to read the state of a button or toggle a LED on or off. And the final chapter is bringing everything together with a JavaFX user interface, a queue system, a queue which is running on the Raspberry Pi, an Arduino which is connected with Wi-Fi to control a LED strip, and a web interface. Now, this is an example we will see later. I also had some talks with the people behind everything related to Java and JavaFX, and what they think about Java on mobile devices, on embedded devices, and what the future will bring. Now, let's start with the basics and what is a Raspberry Pi? It's actually a full PC in a small form factor. Like you see on the left, the biggest one is 9 centimeters. The small one is 6.5. You have different versions depending on the number of connections you actually want to use, because the processor is almost identical in most cases and has the same capabilities. The left one has not that much connections, the A, and the recent one is the Raspberry Pi B4, and you have it in 2, 4, or 8 gigabytes of memory. So that's 40, 60, or 80 euros about these prices. And you also have this Zero, which is a very small board, and has not that much connection, but it has Wi-Fi. You can connect the camera to it, so that's for very small projects. The compute module is a special one. The idea there is that you design your own hardware baseboard, and you click this compute module in it, and then you add the connections that you want to use in your project. So that's if you are really an electronics guy and you want to use this Raspberry Pi in your project. Now, if you look at the B, so the big one, it has 2 4K display connections. So you can have 2 screens. It has Wi-Fi, it has Ethernet, 4 USB ports. So a lot of connections are here. You can also connect the camera directly to it, and then the pins, but I will explain those a bit later. When I started building this presentation, I already used it a few times. It was finished, and then on the 19th of October, I will always remember it because that was my birthday, they announced a new one. So they have a new version of this compute module. It has a bit a different form factor, and there are 32 versions of it, because you can select if you want Wi-Fi or no Wi-Fi, how much memory you want, how much storage you want. The price range is from $25 up to $90. And it's based on the same Raspberry Pi 4 that we've seen before. And they also made available this new baseboard. So the idea of this baseboard, it costs $35, is that you have all possible connections which this compute module provides on one board. So you can use this to experiment, to build your product, to program everything, and then build your own baseboard with only the connections you need, or in the exact same exact dimensions which fit into your project. And that was not the only announcement made the last weeks, because on the 2nd of November, they announced Raspberry Pi that they had the new Pi 400. Now, this keyboard that you see here, that already existed. That's the official Raspberry Pi keyboard. It had already the correct shape to add a Pi inside of it, and that's what they actually did. So the Pi 4, they designed it a bit different, so the board looks different, but it's inside of this keyboard. So you have a laptop without a screen, you can call it. It has no battery either, but it has 2 4K connections. It has a micro SD card. It has the GPIO pins, 3 USB ports, and Ethernet. So this is a full PC within a keyboard, and it costs 70 euros. Okay, remember that, 70 euros for a complete PC. You only need to connect a power supply and a screen to it, and you can get started. Now, where did we see this before? A keyboard with everything inside it? Exactly, that's where it all started for me. This same connector on the back where I connected my relay board to control my Lego trains, you have the same thing here on this Raspberry Pi 400 on this 40-pin connector. There is some comparison we can make, and the most important one is the costs. If you recalculate the price of that Commodore 64 in 1983 to the current euro, it costs 40 times more. The 100 euro you see here is including a power supply. So it's a big difference of what you can do with this cheap hardware, how you get a lot of power in it. This website, 23 fun facts about the Raspberry Pi 400 is definitely something to read. By the way, all the links in this presentation are already on my blog post, webtechie.be, if you want to follow along or check later. Now, what of the biggest difference if you compare this Commodore 64 with what we have now is the screen. This is how you programmed on a Commodore 64, and this is how you program on a Raspberry. The book I've written was mostly done on a Raspberry Pi itself. So I had two Visual Studio Code screens, one with code, one with my book. I had Arduino, I had a terminal, I have a file explorer. So this is a 4K display output of the Raspberry Pi, and you can attach two of these screens to this very cheap board. Another question, why Java on a Raspberry Pi? And I get that question a lot. Wasn't the Raspberry Pi designed for Python? Actually, yes. So when they designed the Raspberry board, they needed a name for it, of course, and they were thinking about a fruity name, like you already had the apple. So it became the Raspberry, and they were using Python and the number Pi, so it became the Raspberry Pi. But in my opinion, it could have been the Raspberry J or something like that, Java, because you can use Java, of course. Why? Because you can. That's my conclusion, and because you will learn. Since I started doing these experiments on this Raspberry Pi, I learned a lot about communications with electronics, with how you communicate and use electronics in your project, and especially in the company I was working, that became important to understand how electronics is controlled. Another argument is Java is eco-friendly. I never thought of this before, but this was a post some time ago. And if you compare the energy needed by a programming language to do similar tasks, you see that Java is very close to C, while Python, for instance, is much needs a lot more power. Java is outdated. It was already mentioned in this conference. Java is dead. Java is old. Well, is it that old? Actually, Python is older. JavaScript, Qt is the same age as Java, and then you had some other language which was mimicking what Java already was doing. They are all older than 20 years. So Java is not older than the others. And since we have this 6-month release cycle, Java is evolving very fast. And JavaFX is following the same release cycle. So we have a lot of new features. We have improvements, also improvements for embedded. In the past, we had Java Mobile or Embedded Edition. I even forgot the name. We don't need it anymore because Java on its own is already powerful enough to run on all these kind of devices. As a side note, these charts, I needed these for my book. I was going to make them first in Excel or Photoshop or whatever, but yeah, I'm a programmer, so I made them in JavaFX. And they are part of the sources of my book. And it only took me a few hours. And I think in Photoshop, as I'm not an experienced Photoshop user, would have taken me much more time to create this. So I just run the application, take a screenshot, and here you have them. Now, if you don't believe Java and Raspberry are a good good match, you can believe Oracle, because I wrote a getting started tutorial for the Java magazine, and it was one of the most liked and retweeted tweets of Oracle in this summer. So if you don't believe me, believe the others. So let's get started and have a Raspberry Pi and use it for our Java experiments. There are a lot of operating systems available for the Raspberry Pi, but I prefer Raspbian OS, which is built by the Raspberry Pi Foundation. You have an imager tool on their website to burn it to these SD cards. It's based on Debian 32 bits. It has OpenGdk 11 if you select the full version. And they also have an experimental 64-bit Raspberry Pi OS. If you select the full version, you will get a lot of tools already pre-installed. Like if you see here for the programming section, that's already a long list. Visual Studio Code is not part of it by default, but since a few weeks, Visual Studio Code itself provides a new release of for ARM and ARM64 devices, so for the Raspberry Pi in this case. That was only the case since a few weeks later. You had to go to unofficial releases of Visual Studio Code. I've written a blog post about this, how to set it up, but it's only a few lines, terminal commands, or you just download it from the website. And of course, you have this Java extension pack as an extension for Visual Studio Code, which contains everything to do Java development on the Raspberry Pi. So we burned this SD card, we have put the Raspberry Pi OS on it, we powered the device, and this is what you get in the terminal. We didn't install anything extra, it was already there, Java minus version, and you have OpenGdk 11 installed on this Raspberry Pi. Now, if you want to go a few steps further and just use whatever is the latest of Java, you can build the OpenGdk yourself. It takes about 1 hour on a Raspberry Pi to run it. You see that the memory usage is not that high. It's using 2.5 gig of the 8, which is on the board. I compared it with my own PC, which is an Intel Core i7, and then it takes about 15 minutes. So it's not even that much slower to build, to do such a big task. And if you then run the version command on this Java version that you've just created yourself on the Raspberry Pi, you indeed get this 16 internal. So that means the not released Java yet, but based on the latest, which was pulled from GitHub. So as OpenGdk is available on GitHub, it's using that as the sources. If you want to use JavaFX on the Raspberry Pi, as it's not a part of the OpenGdk 11 of the OpenGdk itself, you have a few options. One is Liberica JDK from BellSoft. They have an OpenGdk bundle which has JFX included. That means that you can just run your application with Java minus jar and your application, for instance. And don't need to worry about modules or how to add your JFX to it. It's perfect for proof of concept for simple projects. It's also what I used in my book to make it not too complicated to start JavaFX application. What would be better is JLink, GraalVM, Gluon Substrate, of course, as Johan Vos showed us a bit earlier. That's all alternative approaches. To install Liberica JDK, very simple. We get it from their website. We run an install command and link Java and Java-C to that installed Liberica. And if you then request a version with this download, you will get, for instance, 13 BellSoft. And this can run Java and JavaFX applications, very simple. As mentioned, so Gluon is the main maintainer of JavaFX. So on their website, you can find JavaFX early access versions specifically for the Raspberry Pi if you want to do some experiments. And as you can see, you can run JavaFX 16, the latest one not yet released, together with Java 11. And then you get this direct rendering. Direct rendering, that means that the output of JavaFX is immediately pushed to the frame buffer, so immediately to the screen, which is a perfect use case if you want to build, for instance, a kiosk application. So you don't want a user to start any other application or open the browser or whatever. You only have your application on the screen, and that's the single thing that the user can use. The performance is getting extremely good on even on Raspberry Pi. This basefx created by Gerrit Grunwald, I think that's the name we heard in every presentation until now. So he created this basefx game, and as you can see it, this is a video actually running on a Raspberry Pi at nearly 60 frames per second with a lot of animations. I've done some experiments myself. Actually, JavaFX 3D was unknown to me. I've never used it before. I hardly saw it. And some weeks ago, I created a blog post about it to see what has been done in the past and if it still can be used currently with the current state of Java and JavaFX. So I have this Raspberry Pi. On the right, you see my terminal from another PC. To start a JavaFX 3D application. This is using Java OpenGdk 11 and JavaFX 16 early access. And maybe some people will remember this was one of the very first examples of 3D application in Java, which you can control with the keyboard. Another experiment I've done was with FXGL. So this game JavaFX library, which was presented yesterday. And as you can see, it takes a bit to start, and I actually should buy a real camera to do this kind of recordings. This was just my smartphone camera. Here you see an animation with 25 dots with FXGL. And on the left top, you see the frames per second, and it goes up to 30 frames per second, and then it sticks to that. It should reach 60. We are still investigating how far we can go. So if someone has an idea about this or wants to experiment, the code of this performance tester of the Raspberry Pi is on my GitHub, and there's some work to do there to investigate it. Now, back to the Raspberry Pi. And another big reason to use a Raspberry Pi and not just a simple cheap laptop if you want to start programming is this header, these 40 pins that you have on that board and that allow you to connect electronics and talk to the outside world, talk to hardware components. To understand what these 40 pins provide you, I created a small Java Maven library and of course a JavaFX application to show what's inside of it. So there were a few headers in the past, and they started with an 8-pin header. So only 8 pins, and then you had 5 volt on one, 3.3 volt on another, and 4 pins to do something. So do something is controlling something or reading a state from something. I will show you in a minute. Now, then they went up to a 26-pin header, and actually the system on chip, the PC chip they are using actually has 40 pins now. So that's what they provide in this header. And as you can see, there is a lot in there. So you have 3 volt 3, you have 5 volt, and a lot of input-output pins and specific use cases for specific communication protocols with electronics. Now, what is a GPIO, a general purpose input-output pin? That is something, if you translate it to what we understand in computer language, it's a 0 or it's a 1. So for a false or a true. And in electronics, that becomes a 0 volt or a 3.3 volt. So if you want to put on a LED light, for instance, you will put the state to true, and you will get 3.3 volt on this pin. As you can see on this picture, there are some very handy small boards that you can slide on top of these pins, which will make it very easy to find the right number of the pin you want to use. Now, for a LED, so that means on and off a button is push or release. That are the states of these GPIOs. By using these pins, you also have different communication protocols like I2C, SPI, UART. Some devices want to talk in a specific format, and it depends on the number of cables you need between them and the speed of the device. For instance, in my book, you will find an SPI example to control this 8x8 LED matrix. So you only need to send a few commands to end up with a heart, for instance. UART serial communication is used in another example where an Arduino is used to read out the state of a light sensor. A light sensor is not a 0 or a 1, it's a value between 0 and 1024. So to be able to read this, it's easier to use an Arduino, and then you read it through a serial communication and show it in a JavaFX chart. Okay, if you want to get started with this, find yourself 20 euros or a bit more and buy yourself an electronics starter kit. There are a lot of them. Just go search on eBay. Make sure you have enough resistors and LEDs. That's the basic components. And then it's fun to use a distance sensor or a motor or an LCD. There are a lot of available combinations with or without an Arduino or a Raspberry Pi. You will find a lot of them. We're going to use a LED in one of our examples. So a LED is just a little light. It needs a plus and a min. It needs some power. There are some special ones like RGB LEDs where you have red, green, and blue. The simplest one has a connection for each light. If you want to have a white, you have to power on all three of them. And what is also used a lot in these projects is a LED strip. A LED strip is a bit special because each LED is addressable and has its own chip. If you look into this white circle, you have this little square that's actually a chip. So you can address LED by LED. So if you want the 10th LED in your strip to be blue, you can change that one and leave the other ones as is. There's one special thing to keep in mind with these LEDs. They need a certain voltage, and if you give them too much voltage, well, they will light up, but very short and never anymore afterwards. I've done that a few times. So you have to know which voltage they need and adjust it. And as I told you before, the Raspberry Pi, if you put a true or a 1 to it, it gives you 3.3 volts. So you need a resistor in between to limit the voltage, the current going through this LED. And you need to calculate that. And we do that with resistors. And again, a little Maven library I created is used to calculate the value of this resistor. So each color means a certain value. And by using these color bands, you can know the value of this resistor. Huh? So if you select them in this drop downs, you get a value of a resistor. Again, JavaFX application just as a demo case of what you can do with either this library, and on the other hand, how you can build very simple stuff with JavaFX. Now, if you want to know the exact value of the resistor we need to use for our LED in our wire in our electronics project, we give it the input voltage, the voltage of the Raspberry Pi, how much we need for the LED, and then we know that we need the resistor of 55 ohms. An Arduino board normally gives a 5-volt, and then we would need a 140 ohms. For info, I always use a 330 ohm resistor, which is in all these starter kits. And then the LED is not that bright, but it still works. And yes, there is an app for that. And this is one of the, I already had this on my wish list for a very long time. I wanted to create a mobile app with JavaFX. And finally, a few weeks ago, I started experimenting with this with a Gluon mobile project, which you can start in IntelliJ with the Gluon plugin in just a few clicks. And using the same Maven library I already created for my book, I made this very simple application. There's a lot of work still to do. It's just a proof of concept that this works. And together with the Gluon actions, and I just stole this from the presentation of Johan just an hour ago, which he put online on the Gluon website. From the single code base, it goes to GitHub, and GitHub has 5 tasks, and each produce a native application. So you get an executable for Windows, you get a runnable application for Mac, you get one for Linux. And from within the GitHub action, it is pushed to the Play Store. Yes, I have my first App Store application. I will earn a lot of money. I know it's for free, that's true. So it is on both the app stores from the same single code base without any interaction. I have to say that Gluon did a lot of work for me in this. I didn't have any experiments. I don't have a license or a developer account at either of the app stores. So actually these builds come from the Gluon GitHub account. But this is really great. You just create something, you test it on your PC, and without bothering, it just arrives on your smartphone. I say it's proof of concept. The layout is not perfect. It's definitely not pixel perfect. There are people here who are way better JavaFX developers than me and would make this much more beautiful. But I just wanted to prove that this whole flow is working. There is a blog post about it on fuji.io and on my own blog. Okay, back to the goal of this presentation. We want to have a LED turning on and off. I'm just keeping an eye on the time. So we have a button connected to one of the GPIOs, and we have a LED connected to one of the GPIOs with the resistor so that we don't blow it up. This is a simple drawing. Just go to the pictures. You see I have this small breadboard where I have these connections and some wires. I think there is I think there's 2 or 3 euros of electronics components in this picture, except of the Raspberry Pi, of course. Now, let's try this out. You can do this directly from the terminal. So I know that I connected my LED to GPIO number 3. So I can run this in the terminal and say, I want to use pin 3 as an output pin. So if we now write a 1 to this pin 3, then the light goes on. So that's as simple, and with the 0, it goes off again. You see very simple commands, and we have a LED going on and off. I didn't think I promised you rocket science in this presentation, so it's very simple, I guess, but that's the idea of it. It's very simple to get started with electronics. The same is true for a button. So the button is connected to pin 5, and we want to use it as an input pin. Now, if we read the state of this pin 5, it's 0, and if we do it again but push it, it's a 1. Okay, that's the idea of it. Now let's do the same from Java. You see, this is a very basic script, and actually what we're doing here is exactly the same command as we have given before in the terminal. We now use the runtime and execute it, and then 10 times in a loop, we turn it on and off. Yep. My son just arrived. Now, as we are using Java 11 on this Raspberry Pi, that means that we can run Java code without the need to compile it. Oh, that was too fast. So we just open a text file, we copy this code in there. That's exactly the same code as in the slide before. And now we can run this code directly by giving it the Java file. You see, we have our LED going on and off. Now let's make this a bit more programmer friendly and add the Py4G library. This library, and I will go directly to the diagram, you include the Py4G library in your project, and it will directly control the native libraries and the hardware interfaces to the pins. So that means that we don't need to worry about how this communication works, about timings. We just have these native libraries in between and a library that we can address them and use them as we want. Py4G is a project which already exists 6 years ago, 6 years, I think, and it started. And we have this version 2, which is in development. Now, there is some, it's difficult as it is an open source project to further develop it and maintain it. But the idea is to change to a Java 11 basis and a modular approach with support for all the Raspberry Pi boards. And it has the GPIO library, the native library, instead of Wiring Pi. Wiring Pi got deprecated last year, so we need a new base for that. I will also use the Java JFX library because yeah, that's one of the most known, I think, Java AVIX libraries, and it's very handy to build something very fast. This is the application we want to create. It's just using a few of these styles and a few charts, which are also inside this library. Now, to build this project, we need the Py4G library in our dependencies, and we will initiate an instance of the GPIO factory. So that's part of the Py4G core library. For the let, we assign it as an output pin. So we ask our controller, give me an output pin, which is connected to this pin 3. And then turning the let on and off is just becoming as simple as running the let high and the let low command. For the button, it's similar. So we ask our controller to give us an input pin. It is connected to pin 5, just like in the terminal we've seen before, and we can have an event listener connected to it. So this event listener will get every change in this button, and then we can do whatever we want with this event. In this case, I have created a simple class which has an XY chart. So it's a series for one of these charts in the JavaFX library. And whenever the state of the button changes, I get a timestamp and I get the state being 1 or 0. And I add it to this data series. And then the tiles for the application. I only will show 2. So you have this switch tile, and the switch tile has an on switch released event. So for this event, I switch my LED to on or off. And for the chart tile, for the buttons, so we get the button events, so this data series, and we add it to this tile. So no other changes needed here, as everything is controlled by this updatable chart series. So that's where we end up with the setup. So we have our LED, we have our button. I have also a distance sensor. I didn't explain it in detail, but all this is part of the code and of the full article on the Oracle Java magazine website. Oh, I always mess up my videos. Voila. No, there we go. Now we start this screen, this application. You see the small 7-inch display connected to it. So if we switch here the switch tile, then you see the LED going on and off. If we press the button, then we have this chart going up and down. And because we have this distance sensor here, this also on the upper chart, we have a measurement every second. And you see that this chart goes up and down. Okay, we go on. I wanted to do something more with this, especially for this presentation, but I have to admit I failed a bit. I had these 2 distance sensors, and you see on the right that you have this chart again in JavaFX going up and down. I wanted to create something more funny with it, but it's a work in progress. And I have another example. I have a few more minutes left. Okay. It's using the final example of my book, and it's using a Mosquitto queue. So for people who never used a queue before, so the idea is that you have a client which subscribes to a queue. It wants to receive post messages, let's call them like that. We have a sender which publishes messages to this queue, and then the client will receive this. What is the benefit of this? Because in this example, you could just connect the sender and the client directly. The idea is that you can have different senders, different clients, and each client only receiving the messages it wants to receive that are of interest of that specific client. And that's what I set up in this example. So we have the Mosquitto, the queue, we have it installed on the Raspberry Pi. We have an application running on the Pi. We have a PC which can connect with a web browser to this web site provided by the Java application. We can have the same JavaFX application running on another PC, but everything is sent as messages to this Mosquitto queue. And an Arduino board is connected via Wi-Fi and is also a subscriber of this Mosquitto queue, and will then show the requested LED effect on the LED strip. Now, to test this on the Raspberry Pi, we first have to install this Mosquitto and test it. And this is done simply in the terminal. So we have a subscriber which says, I want to receive all the messages sent to testing/test topic. And I want in another terminal, I want to publish something to this topic. And then you see that what you publish here arrives in the other terminal as it is subscribed to this topic. The same can be done if we combine it with a PC. So we still have on the right the Raspberry Pi with the two terminals, and on the left we have a JavaFX application running on a PC and sending a hello from PC to the queue, and then you see that it arrives in the subscribed terminal, but you can also publish from Raspberry Pi and it ends up in the terminal on both the Raspberry Pi and in this data grid here in the JavaFX application on the PC. And then for the interface, again, this color wheels is a component of Gerrit Grunwald, and then some CSS styled buttons to control and send an effect to the LED strips. And a last component, which is part of the Java application with Undertow, is a very simple web page via HTTP handler, so that you can start the red alert effect on the LED strips. Now, if you combine everything and bring this together, then this is where you end up. So you have on the left, you have this JavaFX user interface, which is now running on PC. But as I already showed, you can also run it on the Raspberry Pi itself. And you have here the Arduino, which is connected through Wi-Fi with this Mosquitto queue. So the Mosquitto is running on the Raspberry Pi, so you can see it as our central server in this setup where it provides the queue and it also provides a web application that you can start this red alert, meaning that we have to come to the dinner table and we are at the end of the presentation. Okay, so what did we learn now? Java and JavaFX, yeah, they work on the Raspberry Pi. They are very powerful even. You can do a lot of stuff with it, fun stuff with it. It's nice to combine it with electronics, and you will learn not only more about Java and JavaFX, but also about the electronics itself and how you need to control it and how you can use different kinds of communication with devices. The biggest advantage for me for Java and JavaFX is that you need minimal code to build something very, very beautiful, that you have big results with less code. And if you structure your code very well and separate your objects in a logical way, it's very easy to maintain also your project. And as we have this 6-month release cycle of both Java itself and JavaFX, there are a lot of improvements and new things coming into this environment. So we have native builds of the applications. We have better support for native rendering. We have new frameworks coming for support of the GPIOs and a lot of other evolutions going on. I've published on my blog a link, a new post with all the links of this presentation. Of course, you can follow me on Twitter for everything related to this subject. And you also find a lot of my posts on Py4G.io. So that's the new website for friends of OpenGdk, where we want to share every day a new post about something in the Java world, whether it's a new feature, whether it's a test tool, whether it's a new thing you can build of just developer tips, or all that kind of things. And what's next, of course, for you is to build, experiment, and have fun. That's the only thing I can ask you if you take this a bit steps further. questions, I have no idea. I didn't follow the chat because I'm doing PowerPoint on Windows, so my Zoom is gone. If you tweet about this, please use the hashtag Java on Raspberry Pi. I'm monitoring that a bit to see what's going on inside this kind of stuff. And of course, if you're really interested in this, the book is available on both Elector and Leanpub.
Okay.
That's it.
Thank you, Frank.
I'm on time, I think.
We have some questions.
Yes, shoot.
So you did a perfect stop on the minute.
Okay, wow.
So people are asking about all that electronic stuff that you show. So is it enough to buy your book to understand it, or do you have any book where you say, hey, it makes sense if you want to stop, buy this one?
I'm not an electronics expert at all. I'm a software developer. So what I did is the basics. A LED, putting it on and off, controlling a LED strip. I even use Python for some things. You have this small LCD display. It's very good to have the basics. And then you have a lot of books on electronics. If you check out the Elector website, which is a publisher specialized in this topic, they already do 60 years of publishing everything related to electronics. There you have a lot of books, either for Raspberry Pi, for Arduino, where you can go a lot further. And then it depends on what you want to build. If you're doing home automation, then a relay board is something which will cover a lot of use cases. But then you have people who want to build medical devices or doing temperature measurements, and then you need other sensors. So it's really a new world. That's true. If you step into this electronics, it's amazing how much there exists of components, and especially how cheap they are. If you go on eBay and you look for LED lights, you get, I think, 100 of these small LED lights for a few euros, and you don't have to pay even for the shipment. I have no idea how they do that in China, but they ship stuff for a few dollars or euros, and you get them delivered to your home in a few days sometimes. So yes, it's a big world, and the easy step to start with this is just buy such a box where you have a lot of stuff and experiment with that. And then you can find your direction and see what you actually need to go further and build more of these kinds of things.
Cool, that sounds good. But I assume since you needed to learn that too, there will be a lot of information in your book.
Yeah, of course. Yeah.
You learned it, so you wrote about it.
I have the habit of learning by writing or writing to learn.
Yeah.
That's how you don't know how you look at it. So I just started experimenting and described all my experiments, and then put them in some kind of logical order, and that's how they ended up in the book. So indeed, it's 310 something pages. So there's a lot of info in there. Yeah.
Yeah. So another question was about the Py4G library and what version you are using there together with JavaFX, because some people are saying that for some versions the I2C support is broken in Py4G.
And the Raspberry Pi 4. Actually, I have to be honest. Since I started writing this book, I tried to get involved in the Py4G project, but it's maintained by one single person. It's Robert Savage. And I was able to step into the project and contribute a bit on the documentation for version 2, this version 2, which is aimed at the Raspberry Pi 4 and which has better support for I2C and all this kind of stuff. But he is busy with a lot of other things, and yeah, so it's difficult to go further with this project. We will see where we end up this year or maybe start of next year. But there are also other Dio0, I think, is another similar framework which also provides support with GPIO. So actually, the problem is not always Py4G or the Java, but the underlying native library. And if that library is not adapted for the Raspberry Pi that you are using, then indeed you can have issues. So there was a wiring Pi has been deprecated last year, but there was a fix for the Raspberry Pi 4, but I don't think it covers all the issues that there were, and that's why Pi GPIO is a better choice for the future.
Cool. Okay. So one last question. Somebody mentioned that BellSoft provides builds for ARM and for the Raspberry Pi for Java or OpenGdk 14 and 15 based builds, and even early access for 16. So do you have anything to say about that? Have you tried that already?
I think I stopped at version 13 because I now more use OpenGdk 11 together with the version 16 of Gluon.
Yeah.
Because that one is really made for the best possible support for JavaFX itself.
Okay.
So for the direct rendering mode. So that's really great. So that has really great performance, supports JavaFX 3D, fluent animation. So we can expect a lot of improvements there.
Okay, cool, perfect. Thank you.
Okay.
So yeah, that's good.
Time for some real world app stuff.
Yes. Oh yeah, and Joy is already on. That's perfect.
Hello.
Hey,
Thank you, Frank.
Thank you, Frank. Yeah.
You're welcome. Thanks for having me.